Welcome all. Till now we have seen constant K low pass filter, high pass filter, band pass filter, band stop filter. But there are some disadvantages of these constant K filters. So today we will see what is that disadvantage and why we are going for M-derived filters, because that gives us the solution whatever the disadvantage constant K filters have. So the solution is to use the M-derived filters. So this is the ideal frequency response of low pass filter. So as you can see here, we are having sharp cutoff frequency. We are having sharp cutoff frequency. So after the cutoff frequency, the response decreases very quickly. But in case of constant K filters, after cutoff frequency, the response decreases gradually. It will decreases slowly. So this is the disadvantage. So still in this region, in this portion, still in this portion, we are having some we don't have means we still have we do not have the attenuation. We do not have the attenuation in this region. Attenuation is not zero in this region. So that is the disadvantage of constant K filters. That the response is not sharp. And if I use the M-derived filter, definitely I will get the sharp response. So as compared to this and this, we will get somehow sharp response if we use M-derived filters. So that is the reason for learning M-derived filters. Okay. So the attenuation is not changing sharply. Solution is to use the M-derived filter. Okay. So we will be learning M-derived low pass filter and M-derived high pass filter. So M is basically one factor M. It is also called as midpoint impedance point. It is unitless quantity. M is a unitless quantity. Some factor is there. M is some factor value by which we will multiply the inductors and capacitors. So this is the circuit of M derived low pass filter. So there in low pass filter we have L by 2, L by 2C, but here we have ML by 2, ML by 2, MC, as well as one inductor is there which has value 1 minus M square divided by 4M into L. So now what is the inductor value here? ML by 2, ML by 2. Capacitor value is M into C, and the inductor value, one more inductor we have added in the low pass filter, and that is nothing but 1 minus M square divided by 4M, 1 minus M square divided by 4M into L. The value of inductor is this. Inductor value is not L, capacitor value is not C, inductor value is not L, inductor value is not L. Instead, inductor value is M into L by 2. Whatever is the calculation, that will be your inductor value. 1 minus M square divided by 4M into L. This is the inductor value. M into C. This is the capacitor value. Okay. So if someone asks what is the inductor value in the shunt arm of M derived low pass filter. Once again I will repeat. What is the inductor value in shunt arm of M derived low pass filter? That means 1 minus M square divided by 4M into L is the answer. Okay. Because this is the shunt arm. So your shunt arm consists of one capacitor and one inductor in series. And your series arm consists of two inductors. Basically, this combination is called as one series arm. This combination is called as one series arm. Okay. So this is the diagram of M derived low pass filter. But we already know for for low pass filter, constant K low pass filter, what is value of L, what is value of C, what is cutoff frequency, what is design impedance. That we already know. We just have to calculate the value of M by one formula, and that formula is given by M equal to under root 1 minus f infinity fc divided by f infinity square. So by this formula, we will calculate the value of m, and then if I want to find out the value of inductor here, so just multiply by this m into L by 2, m into L by 2, m into c. And here little bit very different is there, 1 minus m square divided by 4m, that you calculate, then you multiply with L. L is this value. Okay. Then what is this fc? Fc is the cutoff frequency, and f infinity is the frequency at which we have infinite attenuation. That means more attenuation, maximum attenuation. Infinite attenuation means more attenuation. More attenuation means no signal can be passed in the stop band. No, we always want that in the stop band no signal should be passed. So that's why it is the frequency at which we will have the infinite attenuation. That means maximum attenuation. After that, no signal can be passed. So we already know for our constant K low pass filter, L is R0 divided by pi fc, C is 1 upon R0 pi fc, and design impedance is under root L by C, and cutoff frequency is 1 upon pi under root LC. That we already know. We just have to calculate the value of M, and accordingly, what is in the circuit diagram? ML by 2. So just calculate this value. This is the inductor value. Then ML by 2. Once again, we have already calculated C here, 1 by R0 pi fc. So just multiply with M. So MC. Then you have to calculate this factor, 1 minus m square divided by 4m into L. L we have already calculated by this formula, R0 divided by pi fc. So this becomes the circuit of M-derived low pass filter. Okay. F infinity is the frequency at infinite attenuation. Okay, the question is, design M-derived low pass filter having design impedance 500 ohm, cutoff frequency 1 kilohertz, and frequency at infinite attenuation is 1200 hertz. Okay, so what is formula for M? You can pause the video, you can calculate the value of L, you can calculate the value of C, you can calculate the value of M. All these three values you must calculate. You should pause the video and you should try to calculate these values. You know the formulas. Okay, so I hope you have paused the video and you have tried to solve. Now see whether your answers are matching or not. So given is R0 equal to 500 ohm, FC is 1 kilohertz, F infinity is 1200 hertz. So M is given by under root 1 minus FC by F infinity square. So FC is 1000, 1 kilohertz means 1000, F infinity is 1200. So solve these, M value is 0.553. Then L is given by R0 divided by pi FC. R0 is 500, FC is 1000. Solve this, L is 0.159 Henry. Then C is 1 upon R0 pi FC, R0 500, pi 3.14, FC 1000. So its value is 0.64 microfarad. So I hope you have also got these answers. Then you should calculate ML by 2. M is 0.553, L is 0.159, and divided by 2, its value is 44 millihenry. MC, M is 0.553 into C is 0.64 micro. So its value is 0.535 micro. Again, you should pause the video and you should calculate 1 minus m square divided by 4m into L. 1 minus m square divided by 4m into L. Calculate the value. Okay. So now its value comes out as 50 millihenry. Okay. Once we have all the components, we can follow the important step. That means the circuit diagram. Always meaning of designing is finding out component values, and last step and important step is draw the circuit diagram. So ML by 2 is 44 millihenry, ML by 2 is 44 millihenry, MC is 0.05 microfarad, and 1 minus m square divided by 4m into L is 50 millihenry. So this is all about the design of M-derived low pass filter. So this filter and constant K filter, what is the difference? That constant K filter response is after cutoff frequency it decreases gradually, but with M derived after 1.2 kilohertz, after 1.2 kilohertz, there will be infinite attenuation. That means no signal will be passed. More attenuation, infinite attenuation means maximum attenuation. No signal can be passed. So this is the difference between M derived filter, low pass filter, and our constant K low pass filter. So here the range is more after cutoff frequency, but here range is less. And we always want near to our ideal response. Practically it is not possible to get the ideal response, but we always try to achieve the ideal response. Okay, next is M derived high pass filter. Next is M derived high pass filter. So we know that for high pass filter, what are the components? 2C, 2C, L, 2C, 2C, L. In low pass filter, we are multiplying with M. In low pass filter, we are multiplying with the factor M. And in high pass filter, what we will do? We will divide by the factor M. We will divide by the factor M. So it becomes 2C by M, 2C by M, and L by M. And there we have one additional inductor. In low M derived low pass filter, we have additional inductor. But in M derived high pass filter, we have additional capacitor. And its value there in low pass filter, what is the value? 1 minus m square divided by 4m. But here the capacitor value will be in M derived low pass filter, we are multiplying with m. And in high pass, we are dividing by m. And here it is 1 minus m square divided by 4m. So in M derived high pass filter, it will be 4m divided by 1 minus m square. The factor will be 4m divided by 1 minus m square into C. So you should do the comparative study that simply multiply by m that we do in the low pass filter, divide by m that we do in the high pass filter. In low pass filter, the factor is additional inductor is added. In high pass filter, additional capacitor is added. The factor by which inductor is multiplied is 1 minus m square divided by 4m. So the reciprocal of this. So 4m divided by 1 minus m square into C. So this is the diagram of M derived high pass filter. This is the diagram of M derived high pass filter. Then you know that you already know for constant K high pass filter L value, C value, R0 value, FC value. These things you already know for constant K low high pass filter. Just you have to calculate all these values and then you should calculate 2C by M, 2C by M, L by M, 4m divided by 1 minus m square. You should calculate this factor and then multiply corresponding with capacitor and inductor values. Okay. Now here keep attention now. So you know that for low pass filter, what is what is formula for m? M equal to under root 1 minus fc by f infinity square. This is for low pass filter. And for high pass filter, the change is that 1 minus f infinity divided by fc whole square. So this is the change. So you just remember for low pass filter, then you should give some thought process. Then you can write for high pass filter also. Here in low pass filter, fc by f infinity square, and in high pass filter, f infinity divided by fc whole square. Again, fc is called as frequency at which we have infinite attenuation. Frequency at which we have infinite attenuation. Fc is called f infinity is called as fc is the cutoff frequency. F infinity is called as frequency at which we have infinite attenuation. Okay, so these formulas we already know. We just have to calculate these values and we have to accordingly we have to multiply. Suppose I want this capacitor value. The capacitor value is not C. Capacitor is value is 2C by M. Capacitor value is 2C by M. Inductor value is L by M. capacitor value is 4m divided by 1 minus m square into c. So this way you should do some little bit comparative study. So this will be helpful. Okay. If you try to remember both the formulas, you will be confused. So don't remember all the formulas. Instead, remember one of the formula and try to compare another formula. Okay. So some questions. So for that, before solving these 4 MCQ type questions, you should read out the PDF first, or you should go through all the basics first, and then you should try to solve the questions. Okay. So I hope all the basics are clear, so that you can try to solve these MCQs. So question number 1 is, in low pass M derived filter section in T form, M derived, low pass M derived. Okay, you should underline low pass M derived. The shunt arm consists of, what is there in the shunt arm of, what is there in the shunt arm? So this is the diagram of M derived low pass filter. What is there in the shunt arm? Capacitor in series with inductor, or inductor in series with capacitor. L and C are in series. So these are the 4 options. Shunt arm consists of which component? Inductor, capacitor, L and C in series, L and C in parallel. So correct answer is L and C in series. Okay, next question. The series arm of M derived low pass filter section has been obtained. Series arm कैसे मिलता? M derived low pass filter का series arm कैसे मिलता? लो पास फिल्टर का, ठीक है, by multiplying the series arm element by a constant K section by a constant. So in low constant K we just have L by 2. In the series arm we have L by 2, L by 2. But here in M derived we have ML by 2. So we are multiplying by the factor M. So the answer is we are multiplying by a constant M. Okay. Similarly, if I change the question, high pass filter. So what will be your answer? High pass filter, we are dividing. In high pass filter we have 2C. In constant K we have 2C. But in M derived we have, in the series arm we have 2C by M. So it will, the answer will be B. If here it is written high pass, then answer becomes 1 by M. We are dividing by the factor 1, or we are multiplying by the factor 1 by M. Okay. So these are the some possible questions. These are some MCQs. Third one, low pass M derived T section introduces an infinite attenuation pole at 2.05 megahertz. That means F infinity is given, while the cutoff frequency is 2 megahertz. That means Fc is given. The value of M is. So you should pause the video. You should try to calculate. Okay. So I hope you have paused the video. So we know that what is the formula? M equal to under root 1 minus Fc by F infinity square. So just put the values, use calculator. You will get the answer as, don't simply watch the video. You should also get, you should have paused the video. Then only it will be useful. So the answer is 0.21 is the answer. So M value is 0.21. By substituting Fc F infinity, you will get the answer as 0.21. I hope you have got this answer. Next question. A low pass M derived T section having M equal to 0.2, L equal to 3 millihenry, C equal to 1.2 microfarad. Find the inductor in shunt arm. Low pass diagram you must draw. So M given, L given, C given. We have to determine the inductor in the shunt arm. So M derived low pass filter. This is the diagram. Again, you can pause the video and you should try. And then you can see the solution. So shunt arm is this. They have asked what is the value of inductor in the shunt arm. What is value of inductor in the shunt arm? What is the formula? 1 minus m square divided by 4m into L. So that becomes m given is zero point 0.2. So 1 minus zero point 0.2 square divided by 4 into zero point 0.2 into inductor is 3 millihenry. Inductor is 3 millihenry. So just use the calculator. I will ask you what is the answer for this question. Okay. So we will stop here. Thank